In this video, we're going to see what happens if we try to compare variables or values of reference type for equality. We're going to see how this differs from what happens if we try to do the same thing to values of value type. And we're going to look at what are some of the ways of comparing things for equality without using the equality operator. So let's just jump straight into some code. So I'm going to start by comparing two integers for equality. And we already know how to do this. I'm going to make a variable called 2. I'm going to make a variable called sum, which is 2 plus 2. I hope that we end up with 2 plus 2 being equal to 4. Remember that we use the double equals to say we are comparing these things for equality. We use the single equals to say we are assigning a value. You notice that I put, just as a little aside, parentheses around the double equals here. That was not necessary. The double equals has higher precedence than the single equals. But I always figured that when I am mixing double equals and single equals, people's eyes are already glazing over, right? It's already difficult to read. I want to make it super, super clear what's going on here. So I'm going to say the sum is equal to the value 4. That is a test for equality. It's a Boolean value. And then I'm going to assign that Boolean to this variable, compare integers, right? So let's see what happens here. Oh, it's true. OK, good. OK, the system works. All right. What about strings? We can do the same thing for strings. We're going to say that this string is hello. And then we're going to concatenate the two of them together. We're going to say hello, hello. And naturally, we get hello, hello. And now we'll say the same thing. Is this concatenated string equal to this literal string? And I sincerely hope that the answer is yes. And it is. It's true. All right. What about arrays? So we're going to say we have an array, ABC. It has 3 elements. You can see that over here, they show up in the locals window. Then we're going to say DEF is equal to ABC. Now, you remember from last time what happens here, right? We have an array, a collection of 3 elements. It's a blob somewhere off in the storage of the computer, right? We have a variable, ABC. It refers to that blob. There's an arrow pointing to it, right? Now DEF gets a copy of that arrow, right? So ABC and DEF are both referring to the same array, right? So if I ask, are these two references equal, we would certainly hope that they would be, because we just assigned the value of one to the other. And sure enough, that is true. All right. So what if we do this? What if we say, I want to make a second array, GHI, that's also equal to the same elements, 10, 20, and 30. All right. So now what's going to happen here? Well, you remember from the previous video that this creates an entirely different array, right? So ABC and DEF are now both referring to some blob of memory over here, right? GHI is referring to some blob of memory over here, right? They have the same contents, right? They're both a collection of 3 variables, and the values of the variables are 10, 20, and 30. Are they considered the same? Oh, the suspense. We'll find out. That is false. So by default, C# will compare 2 references to see if they refer to the same thing, right, to the same object, we say in object-oriented programming. And in this case, they do not, right? Those 2 arrays, those 2 objects, have the same contents, but they are not the same thing, right? And in fact, if we mutated one of them, here's something that I haven't shown you yet. We can go in here in the locals window, and we can highlight the value of this array, and we can actually change it right there. Instead of having to write a program that does it. And sometimes when you're running a program and you think, oh, this isn't quite right, I wonder what would happen if I changed this, it's a handy way to debug your program. Just remember, this only happens while the program is actually running. You've just changed the state of the program without writing any code. The next time you run it, it's not going to remember that, right? But we can see we just changed ABC, right? We've changed DEF as well because they refer to the same array, right? But we did not change GHI, right? It refers to a completely different array that just happened to have the same contents, right? So it kind of makes sense that we would want to say these 2 things, ABC and GHI, are not the same thing because if they were the same thing, you would think that if I did one thing to one of them, then it would happen to the other, right? If they were referring to the same things. I made an analogy in the previous video about houses with addresses, right? Now, if I have a house at 123 Sesame Street and I build an identical house at 124 Sesame Street, then the addresses of those houses are different, right? Even if the houses are identical, right? So the references are not the same. And indeed, if I made them not identical, if I painted the house blue on one side of the street and red on the other side of the street, then clearly they would not be the same thing anymore. So it kind of makes sense that these references should not be the same. The problem with this is it looks like they should be the same. It looks like we should be able to say, well, these two things have the same contents, so why aren't they the same? I'm using the equality operator. So what I like to do in situations like this is there's a special method in C# called reference equals, right? And if I'm comparing two things to see if they are both referring to the same object, right, then I use reference equals because it is super clear in the source code now that I am doing a reference comparison here. Right? So let's try this out. So I'm going to compare ABC to DEF by reference equality, and that one is true. And I'm going to compare ABC to GHI using reference equality, and that one's false. So essentially, it is the same as the equals equals operator. This is just a way that some people find is more clear to read. OK, so I said in the previous video that strings were reference types, and yet we compared these two strings here. We compared concatenation and this literal, and they came out as being equal. Now, are they reference equal? Well, we can find out. We have this method, reference equals. Let's call it and see what happens. OK, that's false, but this one was true. So what's going on there? Well, it turns out that they are not reference equal. We know that they're not reference equal because we called reference equals on two references, and they came out different. So what's going on? Well, C# knows that when you are comparing strings for equality, you almost always want to know, are the contents of this string the same? Right? If you have a string and it contains an address, and you extract the country from that address, and you then compare that to the literal string Canada, you don't want to know, oh, does this one refer to one piece of memory that says Canada, and this one refers to a completely different piece of memory that says Canada, and therefore they're not equal. No, you always want to know, are their contents the same? So there is an exception made for strings and for certain other reference types, the details of which too complicated to go into in this course. But strings are compared as though they were values. They are compared by their contents unless you force the compiler to compare them by reference by using the reference equals method. There is also a method called equals. And so let's see what happens if we call that. Right? Now we've compared the strings using equals. That is true. Right? So the equals method essentially does the sensible thing to do. Right? It compares values by value. It compares strings by values. It compares references by reference. Right? If I compare now, you notice this is a static method, right? It didn't have a receiver. In fact, it didn't have a receiver at all, right? Normally, we would normally every method that we've ever seen has been of the form something dot something, right? There's always a receiver. Sometimes the receiver is a type in the case of a static method. Sometimes it's a value in the case of an instance method. We seem to have method calls here that don't have anything at all. It turns out that the receiver for reference equals is a type that I mentioned very, very early on in our video about types. It's the type object. Right? So we could say object.reference equals. It turns out that for reasons that are a bit tricky to explain, you can omit the receiver when the receiver is object. So I just left that out. And it's common to see it both ways. Sometimes you'll see object.reference equals. Sometimes you'll just see reference equals. The same is true of equals. Now, there is an instance form of equals as well. So the concatenation variable is a string, right? And I can call a method with it as the receiver called equals, and I can compare it to hello, hello. And this method also does the sensible thing, right? It's equal to true, right? The difference between these two is suppose concatenation were null, right? I can call the static version of equals, pass in a null value, a null reference for the concatenation here, and then it will say, oh, it is false that the null reference is equal to this particular string, right? It will not crash with a null reference exception. Whereas if I have concatenation equal to null here, and then I try to dereference it by calling the equals method, that would produce an exception. So that's a minor difference between the two. Otherwise, they're almost identical. And finally, here is an interesting question. What happens if I try to do reference equality on things that aren't even references? What if I try to do reference equality on these two values? What do you think is going to happen? It's very suspenseful. Turns out that that is false. These things are not references at all. And so it is false that they refer to the same thing, right? That's kind of a subtle point. And the mechanics of what is actually happening behind the scenes here are a bit tricky to explain. I would have to explain a special kind of conversion called a boxing conversion. And it gets to be a bit tricky. The practical upshot is never, ever try to do reference equality on things that are not references. It simply will not work. You will just get false. They do not refer to the same thing, even if they have the same values. So summing up, there are a confusingly large number of ways to compare for equality in C#. We've already seen there's the equals equals operator and the bang equals inequality operator. There is the reference equals static method. There's the equals static method. There's the equals instance method. And there are actually a bunch more different ways to compare for equality that I did not cover in this video. We're not going to talk about in this course, that allow you to define your own custom ways of comparing things for equality. And it all gets quite tricky. It turns out that equality is a problem that is not entirely solved to my satisfaction in any programming language. It's surprisingly difficult to figure out if two things are the same. We saw that strings are, by default, compared by value. What are the contents of the strings, even though strings are reference types. If you force strings to be compared by reference, then they will, in fact, tell you, oh, this string refers to a different piece of memory than that string. But typically, you would never do that. Arrays are always compared by reference. So if you have two arrays, you compare them for equality. It will tell you, do these two references refer to the same array in memory? And use reference equals, the static method, when you absolutely, positively want reference equality and you want it to be super clear in the code that that's what you're doing. Never use it on value types.